Hey everyone, welcome to lesson 3.7. Today we are going to factor simple trinomials. So in preparation for factoring these kinds of trinomials, I'd like for you to think about these products and sums. So let's start by looking at part A here. So 5 times 2 just gives us 10. So those two numbers that multiplied to 10, if we took those same numbers and we added them together, we would get a sum of 7. Now let's think of another way to multiply to positive 10. Well, another way to do that would be to take negative 5 times negative 2. That still gives us positive 10. Now if we took those two numbers, negative 5 and negative 2, and added them together, we actually get a sum of negative 7. Now let's think about how can I multiply to negative 10. Well, one way to do that would be to take negative 5 times positive 2. And if you took those two numbers and added together, this time we would get a sum of negative 3. And finally, another way to get to negative 10 is if the 5 was positive and the 2 was negative. And if we took those numbers and added them together, then we would have a sum of positive 3. So just as a note, let's quickly read through this. Okay, so with that in mind, we're going to use that idea to fill out this chart. So we've got a column here for product, a column here for sum, and our job is to figure out the two integers that multiply to the product and add to the sum. Now it's always easier to think of the product, or it's easier to list the ways that you can multiply to a certain integer versus the way that you can add to an integer, because there's infinitely many ways that you can add to 5, but there's only so many ways you can multiply to 6. So for example, we can do 1 times 6, we can do 2 times 3, and we can think of negative 1 times negative 6 and negative 2 times negative 3. All of these will give us a product of positive 6. But only one of those ways, the 2 and the 3, if we took 2 plus 3, that would give us 5. So the two integers that we're looking for are 2 and 3. This time we want to think of the two numbers that will multiply to negative 6 and still add to positive 5. So kind of make a list of all the ways that you can multiply to negative 6. And so the one way that you're actually going to add to positive 5 is if you take the positive 6 and multiply it with a negative 1. The product will give us negative 6. The sum will give us positive 5. So I'll do one more with you, and then we can pause the video, and I'll let you guys fill out the rest of the chart. So two numbers that multiply to 30, but then add to 11. I know that 5 times 6 gives us 30, and I know that 5 plus 6 gives us 11. So this is exactly why I make you guys do Math Minute so much, is because of the multiplication. I want you guys to be really, really good at multiplying the two numbers and seeing if those two numbers, after you multiply them, if those same two numbers will add up to the desired sum. So here's where I'd like for you to pause the video and just kind of fill out the chart on your own and see if your answers match mine. Okay, so at this point, hopefully you've had a lot of practice with this, and hopefully you're comfortable with thinking of two numbers that multiply to a certain product and those same two numbers that add to another sum. So we're going to take this and we are going to move on and see how it's applied to factoring. So like I said, we are looking at simple trinomials today. In a few days we'll look at complex trinomials. In a simple trinomial, it is in this form, ax squared plus bx plus c, where the coefficient on the x squared term is just 1. So right now we're going to do the opposite of factoring. We're going to distribute. So if we take a look at this first question here, we have x times x, we have x times 3, we have 2 times x, and we have 2 times 3, which gives us 6. Now if we simplify, we end up with x squared, 5x, and 6. So what we've done is we went from factored form to expanded and simplified form. Now factoring is the reverse of that. Factoring would be I would give you this question here, or this expression here, and then I would ask you to put it back into the brackets. So what you're looking at is you want to look for two numbers that multiply to the last term and add to the middle term's coefficient. So if you think about it, you want to find two numbers that multiply to 6 and add to 5. And if you think about it, because we've done the practice already, two numbers that multiply to 6 are 2 and 3, and those same two numbers, 2 plus 3, also gives me 5. And now notice how those were the two numbers that are in the brackets. So if you're okay with that idea, I'm going to just kind of skip ahead, and let's actually get to the factoring practice. Okay, so as I already explained to you, factoring is the opposite of expanding. So when you're factoring, you're trying to find which values you need to multiply together to get a certain product, and those same two numbers have to give you a certain sum. So again, we focus on the last term. Those are the two, that's the value you need to multiply to, and the middle term's coefficient is the one that you need to add to. So let's put that idea into practice. So I'm looking for two numbers that multiply to 12. Sometimes people write out P for product. Two numbers that multiply to 12 and add to 7. So the middle term's coefficient. Again, it's usually easier to think of the ways to multiply to 12 versus the infinitely number of ways that you can add to positive 7. So if you're stuck, one way that you can kind of tackle this is to do a factor rainbow. And so what I mean by that is we're going to start with the number 1, and 1 times 12 will give us a product of 12. And then right next to the 1, I'm going to write a 2, and I know that 2 times 6 will give us 12. And I know that 3 is also a multiple of 12, so 3 times 4. That also gives us 12. And now it's called a factor rainbow, I think, because you start off, if you look across the top, you have the numbers 1, 2, 3, and then you know you haven't missed anything because the next number is number 4. So you know that you've pretty much taken care of all of your possible values. And then you kind of look at the columns and you say, okay, well, I have a 3 and a 4. I know that 3 plus 4 will give me 7. And the way that this works out is very simply, you're going to write one bracket that has an X. You're going to put in your positive 3 as the first number. And then in the second bracket, you put your variable, and then the other number that also multiplies to 12 and adds to 7 will give you the plus 4. And so that is fully factored. Okay, again, let's try. So we're looking for two numbers, but this time multiplies to negative 12 and adds to negative 4. So again, we're going to open up these two brackets, and in one bracket we're going to get an X, and the other bracket also starts with an X. Let's think of these two numbers. Well, two numbers that multiply to negative 12 and adds to negative 4, I would say would be negative 6 and a plus 2. If you ever wanted to check your work, know that you can always expand your answer by doing distribution, and you should get the original question back. Okay, in the next couple of examples, notice that we're not working with one variable anymore. We have two variables, but they're still in a simple trinomial form. Notice that the coefficient on the first term is still 1, and notice that in our first variable there, we have x squared. In the second term, the exponent goes down by 1, and in the last term, there's no x value at all, or x variable at all. And with the other variable, it kind of goes the other way. It goes in ascending order. There's no y in the first term, but there's y to the power of 1 here, and then there's y squared there. So if you have a trinomial that's in that form, it's still factorable. You're still looking for two numbers that multiply to the last term here. So multiply to 20 and add to 9. The only difference is how you put the variables inside the bracket. So because we have x, we're still going to have x on the left side of the bracket here. And then two numbers that multiply to 20 and add to 9 are going to be 4 and 5. So instead of just putting a +4 and a +5, we're going to put +4 and then the second bracket, or the second variable, so +4y, and then +5y. So the exact same process, except you're going to attach your second variable to the end there. And again, if you're not too sure, expand using distribution and simplify your answer, and you should end up with the exact same question you started with. Alright, now let's take a look at questions I and J. At first glance, they don't look like simple trinomials. Notice that the coefficient for our x squared term is not 1. So our first job is to think, can we common factor? So whenever you're tackling any kind of factoring question, you always want to common factor. So I'm looking at this and I see that all terms are divisible by 2. So I'll factor out the 2, leaving me with x squared plus 7x and then plus 10. And then what remains inside the bracket here is a simple trinomial. So this time we want to look for two numbers that multiply to positive 10 and add to positive 7. So now that you've factored out this 2, it's just kind of going to go along for the ride now. We don't forget to write it. You have to write it for every step. But if we just kind of focused on what's inside the bracket, we know that we are going to have x, and then these two numbers actually work out to positive 5 and positive 2. So 5 will go here, and then x plus 2. Okay, so one extra step here with the factoring, make sure that you common factor first. Otherwise, what's going to happen is you'll have one of these brackets that still has something common in it, and it's not fully factored if that's the case. So in this case here, I am hoping that all of the terms are divisible by -3, so let's try that out. So that is it for today's lesson. Again, if you have any questions, make sure you write it down, and we'll have lots of time in class tomorrow to take those up. Thanks so much for watching. Have a great night.